Request from one of the math worksheets is to find the derivative of this function evaluated at x equals e. So in this function, the base and the power both contain x, neither are constant. So our process for taking the derivative of such a function begins by taking the log of both sides. So the ln of the left side, the ln of the function f, equals the ln of the right side, the ln of x to the power of ln of x. One of the log properties we can use allows us to take the ln of x that's in the power and bring it down in front of the log that's outside. Now, not just because x to anything, x to the a, ln of x to the a, we can bring the a down. Ln of, I'll write it down. The rule here, ln of a to the power of c is c times ln of a. That's the rule that we're using. So ln of f, nothing changes there, equals ln of x multiplied by ln of x. Looks weird, we'll keep going. On the left-hand side, we have a something that looks like the ln of w. When you take the derivative of ln of w, you get w prime over w. When you take the derivative of ln of f, you get f prime over f. F is a function in the same way that w is a function. On the right-hand side, we have an a times a b. So we need a product rule. So product rule says we'll have a times b prime, so ln of x, times the derivative of ln of x, which is 1 over x, plus b times a prime, also ln of x times 1 over x. It's the same piece. Cross multiply by f to get f prime all by itself, so f multiplied by ln of x over x plus ln of x over x. Simplifying a little bit, f is our original function, x to the power of ln of x. And then the rest I'll just copy down again. Well, maybe not, we'll simplify. They both have the same denominator, so we can add the numerators. We have 1 times ln of x plus another 1 times ln of x, so that's 2 of those, 2 times ln of x over x. Now we'll evaluate f prime of e. So I'll have e to the power of ln of e times 2 times ln of e over e. Ln of e is 1, so we have e to the 1 multiplied by 2 times 1 over e. E over e cancels, and we get 2. That's the answer for that question. I think it was, what was it? I think question 3G or something like that, on one of the sheets, maybe in the math review, the test 1 review sheet. I can't remember which one. Okay, next question was number 4 from the same sheet, and it's asking for the slope of a tangent line to a curve at a point. And the way we find slopes of tangent line is we take the derivative of the function and evaluate the derivative at the x-coordinate. So first I'm going to take the derivative, y prime. This is a w to the power of 2. So we take the derivative of a function to the power of 2, the power comes down. We have our original function to one lower power, so power 1, and then multiply by the derivative of the inside. The derivative of 3 is 0, it's a constant, it's not multiplied by a function of x. Derivative of ln of x is 1 over x. Okay, next, I'm going to simplify this in some bizarre looking ways. I'm going to write this as 2 times 3 plus the ln of x, and then this 1 over x I'm going to rewrite as x to the power of negative 1, just because you're allowed to do that. Now let's evaluate this. Evaluate at x equals 1 over e. So that'll be our slope m. We'll have 2 times 3 plus the ln of 1 over e times 1 over e to the power of negative 1. So I can rewrite this 1 over e as e to the negative 1 using the same exponent law. So e to the power of negative 1 up in there, and then multiplied by, when you have a negative exponent, you can absorb the minus sign into flipping top and bottom of the fraction. So this is just going to be e over 1 now to the power of positive 1. Let's keep going. 3 plus, and then ln e cancels using the cancellation law. So we have 3 plus -1, so 3 minus 1 times e. And then 3 minus 1 is 2. 2 times 2, 4. 4 times e. The answer. So that's the slope to the curve at that given coordinate. And the last question that was requested was to find the derivative of a function at 0. So when I take the derivative of this is log base 5 of a function w. We're going to get w prime divided by w times the ln of 5. Need a ln 5 down there because this is a log function of the base of 5. So plugging in what w prime is, derivative of x to the 5 is 5x to the 4. Derivative of 5 to the x, it's an exponential function, we get 5 to the x ln 5. And then derivative of 5x is 5. Down below, we have original function, w. So, what was that? X to the 5 plus 5 to the x plus 5x. And then that is multiplied by the ln of the base of the log function. So multiplied by the ln of 5. Now we plug in 0. So f prime of 0, we're going to have 5 times 0 to the 4, so 0 plus 5 to the power of 0 times the ln of 5 plus 5, all divided by, so downstairs we're going to have 0 plus 5 to the 0 plus 0 multiplied by ln 5. And then this cleans up. Anything to the 0 is 1. So on top we get ln 5 plus 5. On the bottom we get 5 to the 0 is 1 times ln 5. So we get ln 5. That'd be the answer there.